Hi, I'm Matt, and in this video I'm going to talk about how we could extend the typical product rule for derivatives to 3 or more functions. Before I go forward, I do want to say if you're not already comfortable using the product rule for 2 functions, I suggest you do a little bit more practice with that before looking through this video. But now, onward. So first off, I'm going to review what the product rule is for 2 functions. And the product rule says that the derivative of g of x times h of x is equal to g prime of x times h of x plus g of x times h prime of x. And I'm going to go into the form of this a little bit because it will be helpful when we go to more numbers of functions. So we see that for the derivative of the product of 2 functions, we end up with the sum of 2 functions. And in the first term, we have g prime of x, while in the second term, we have h prime of x. So we see again that we have the product of 2 functions, so we get now the sum of 2 terms. And in the first term, we're differentiating the first part of the product. And in the second term, we're differentiating the second part of the product. Keep that in mind as we go forward, because now we can extend this to 3 or more functions. So now, how exactly would this work for 3 functions? When we have the product of 3 functions and we're differentiating it, we're now going to get the sum of 3 terms. So just as when we had the product of 2 functions, we got the sum of 2 terms. Now when we have the product of 3 functions, our derivative is going to be the sum of 3 terms. And then in each term, the derivative is going to be moved to a different function. So what I mean by that is that let's say we have a function g of x times h of x times j of x. What we're going to find is, again, we're going to have the sum of 3 functions, or 3 terms, I should say. Then in the first term, we're going to have g prime of x. In the second term, we're going to have h prime of x. And in the last, or third term, we're going to have j prime of x. And then, again, for the first term, it's g prime of x, h of x, j of x. So we see that in the first term, we differentiate the first part of the product and keep the other functions. In the second term, so g of x, h prime of x, j of x, we differentiate the second part of the product and then just keep the other terms, so g of x and j of x. And then in the third part of the sum, or the third term, we keep g of x and h of x and differentiate the third part of the product, hence the j prime of x. So this pattern of the number of functions we're multiplying be the number of addition signs we have in our product rule will stand for more than 3 functions. Similarly, this pattern of the derivative being moved to the right in each term of the sum will also apply when we go to higher numbers of functions. So again, when we go to more than 3 functions, all the same rules apply. We just essentially get more terms to sum together. So now, how do we use the product rule to compute derivatives when we have more than 2 functions? Pretty much the steps are going to be the same as 2 functions. So now, since we have 3 functions, we're going to write f of x is equal to g of x, h of x, j of x. And then we're going to identify what g of x, h of x, and j of x are. This will just decide by g of x will be our first part, h of x will be our second part, and j of x will be our third part. And now we're going to compute the derivatives of each of these functions. So g prime of x, h prime of x, and j prime of x. And then from there, I know it's long, but we're going to write our complete product rule for 3 functions. And then we're going to plug in our results into the product rule, and then write our answer neatly. Again, these are the same steps as we use for product rule with 2 functions, just now we have an extra function and an extra term to work with. So now we're going to try an example of this. So let's say we have f of x is equal to x squared sine of x times the natural logarithm of x. The first thing we're going to do is write f of x as the product of 3 functions. So I'm going to write f of x is equal to g of x times h of x times j of x. And now we're going to identify what g of x, h of x, and j of x is. So g of x is going to be our first term, so that's going to be x squared. H of x is going to be our second term, so that's going to be sine of x. And then j of x is going to be our last part, which in this case is the natural logarithm of x. Now that we've identified what g of x, h of x, and j of x are, we need to find the derivatives of each of these functions. So we're going to start with g of x and find g prime of x. As x squared is a polynomial, we could use power rule, and doing so gives us that the derivative of x squared is 2x. Next, we need h prime of x, and for this one, we're going to have to use our rules for the derivative of trig functions. And that rule says that the derivative of sine of x is going to be cosine of x. And lastly, we need to find the derivative of j of x to get j prime of x. For this, we're going to use our rules for logarithmic functions, and that says that the derivative of the natural logarithm of x is 1 divided by x. Now that we have our derivatives of the functions and we have our functions initially, we can now write and plug into the chain rule. So now we write that chain rule as d dx of g of x times h of x times j of x is going to be equal to j prime of x, h of x, j of x plus g of x times h prime of x times j of x. Finally, plus g of x times h of x times j prime of x. And now that we wrote that, we can now plug in functions. So we'll have that d dx of, I'm just going to write f of x here for simplicity. It's going to be equal to g prime of x, so that's 2x, times h of x, which is sine of x, times j of x, which is the natural log of x. And now we'll move on to our second term. G of x is x squared, h prime of x is cosine of x, and then j of x is again ln x. And now we move to our final term, where we have g of x is again x squared, h of x is sine x, and this time j prime of x is 1 divided by x. So now what we have here is our derivative. We're just going to write it neatly and simplify it a little bit. So now to start off writing our final answer, I'm going to write f prime of x. And there's no simplification that can be done to our first term, so I'm just going to copy it down. 2x sine of x ln of x. Similarly, for our second term, there's no simplification to make, so we get x squared cos of x ln of x. And lastly is our third term, but there's a simplification we can make. Because x squared times 1 over x, we get that in x cancels. So we're just left with x sine of x. And this here, f prime of x is equal to 2x sine of x ln of x plus x squared cosine of x ln of x plus x sine of x is our final answer. And this is how we would use the product rule for more than two functions, in this case 3, to compute the derivative of a complex product. So now here are two questions for you to try on your own. So the first question gives you f of x is equal to a of x times b of x times c of x times d of x, and just asks you to write out the product rule for these four functions. So to do this, you'll use the pattern I brought up at the beginning of the video. And for problem 2, find the derivative using what we already did to find the derivative of 3x cubed e to the x cosine of x. The solutions will appear in 5 seconds. So for the first one, you should have gotten that the derivative was f prime of x was a prime of x, b of x, c of x, d of x, plus a of x, b prime of x, c of x, d of x, plus a of x, b of x, c prime of x, d of x, plus a of x, b of x, c of x, d prime of x. So just to talk about this a little more, again, here we were given the product of 4 functions, so we see that we have 3 addition signs, as our solution will be the sum of 4 terms. Similarly, you see that we just, again, move the derivative from each function from left to right. So we started with a prime of x, the derivative of the first term. Then in our second part of the sum, we had b prime of x. In our third part of the sum, we had c prime of x. And in the fourth term, we had d prime of x. So again, this shows further what I meant earlier when I said we move the derivative just from one term to another in the sum. And for problem 2, going through the same way we did the example, you should have gotten 9x squared e to the 2x cosine of x plus 6x cubed e to the 2x cos of x, and then minus 3x cubed e to the 2x sine of x. I hope you got these. If not, feel free to leave any questions or comments you have below. Thank you so much for watching. Have a great day.